This is our last video for the measurement unit. In this video, we are going to go over the metric system, how to convert from one unit to another. So going like grams to kilograms. And then we also will finish up with a quick calculation of percent error. So first thing, I love the metric system. It is so much easier to use than the English system. If we had the metric system, we wouldn't necessarily have to worry about all of the dimensional analysis that we just did in the last video, because if we were solely on the metric system, everything is based on 10. So all we need to do is shift our decimal place over a couple of places to get our new number. We don't have to worry about dividing by 12 or 5,280. But we need to use both systems. We need to use the English system because that's what our country uses, and we need to use the metric system because that's what we use in science. So you need to be familiar with both. All right, common base units of the metric system. Reference table D, we've got length would be meters. We're relatively familiar with that. 1 meter is about 3 1/3 feet. Mass, we're going to be measuring in grams. Sometimes we'll be measuring in kilograms, but gram would be the base unit. Volume is liters. Energy is joule with a capital J. We'll be talking about that a lot throughout the year. And pressure has a couple of different units, but the metric one is Pascal. And again, all of these symbols are on your reference table on table D. So if you get stuck and you're not sure what something's measuring, you want to take a look at table D. And hopefully you're looking at table D right now, and there's actually a whole lot more things on there than these ones that I mentioned. Okay. So then our metric system gives us our different prefixes and our different meanings. And most of these are going to be on reference table C. So kilo is abbreviated with a K, and what that means is 10 to the third or 1,000. And this is a pretty easy one. So we know that a kilogram is 1,000 grams. A kilometer is 1,000 meters. Hecto is not on your reference table, so you won't be tested on hecto, but you could have some homework questions on it. That is 10 to the second, so that has a factor of 100. So a hectogram would be 100 grams. A hectometer would be 100 meters. Deca is 10 to the first or 10. That's an easy one to remember because decade is 10 years. So when we see no prefix, so just our base units, so like meter, liters, joules, grams, and so on. That has a value of 10 to the 0 or 1. That will be important when we talk about our conversions in a minute. Deci is where our fractional ones start. So 10 to the negative first, so 0.1 or 1/10. So a decimeter would be 1/10 of a meter stick. Centi is one that we're pretty familiar with because of centimeters. So that would be 1/100th of a meter stick. So a centimeter, we know about what size that is, and there's 100 centimeters within a meter stick. So 1 centimeter would be 1/100th of a meter. Milli, those are those very, very, very tiny markings on there, and that would be 1/1000th. So milli is 10 to the negative third, so 1/1000th. So a milligram is 1/1000th of a gram. A millimeter is 1/1000th of a meter. Then we have some additional ones. Micro is 10 to the negative 6. So that would be decimal, 5 zeros, and then a 1. So this would be 1 1 millionth. So a micrometer would be 1/1 millionth of a meter. So that's where, we wouldn't really be able to see that with the naked eye. You would need a microscope. Nano is 10 to the negative 9. So when you hear about nanotechnology, they're talking about very, very tiny things. This is 1/1 billionth, or 1/1 billion. And then picometers are what atoms are measured in. So that gives you an idea of how tiny our atoms are. That is 1/1 trillionth. All right, before we get to our conversions, just going to go over a couple of basic things. So what would we use? Distance between two cities. We would normally use miles. So if we talk about okay, here to Buffalo is, a little bit less than 60 miles. If we are in Canada, where they use the metric system, then we would be expressing that distance in kilometers. Volume of a container of milk. So we go to Wegmans or Tops and we buy a gallon of milk. In Canada, we would be buying that in liters. All right, if we are measuring our weight, we are going to do that in pounds. If it's a newborn baby, pounds and ounces. In Canada, we would be doing that in kilograms. The length of a pen, we could do that in inches, is what most people would do, but I would actually prefer to do that in centimeters or millimeters. I like working with centimeters and millimeters easier. I feel like it's easier to count, like it's 7.8 centimeters. A mass of a candy bar, that would be here measured in ounces, but with the metric system, we would be using grams, and that again is what we will be using in class. Time for a class period is minutes. How tall you are. I say I'm 5'4", but in Canada, they would be doing meters and centimeters. And then radius of an atom, since those are so tiny, we would need picometers for that. Okay, so now we have our metric system conversions. There's a couple of different ways to do these conversions, so I'll give you a couple of options. You find out what works best for you. First way, if you can do it using the knowledge that you have in your brain, fantastic. That's going to be your quickest method. So 873 centimeters equals how many meters? Well, if you know that there's 100 centimeters per meter, then you would know that this would be 8.73 meters. So if you know that, great. Do them like that when you have ones that you know. Now, if you are not as comfortable with metric system and you didn't know that, that's okay. There's a couple of other ways that we can do it to get the answer. We can use our reference table. So on table C, you want to look up those factors. So centi is 10 to the negative second. M stands for meter. That's a base unit, so that's 10 to the 0. Remember I said I was going to come back to the 10 to the 0 in base units. So this tells me I need to move my decimal 2 spots. Because the exponents differ by 2. Now my unit, centi, is pretty small, 10 to the negative second. It's getting bigger. A meter is bigger, so my number has to decrease. So I go 2 spots over to the left to get 8.73. So that's just a nice fallback method to do it if you're not familiar with them. Okay, so number 2. Again, if you can do this in your head, yay for you. That is fantastic. So 0.05 liters into milliliters. let's use this method that we just did last time. So liters, that's a base unit, so 10 to the 0. Milliliters is 10 to the negative third. So now I'm going to need to move the decimal 3 spots because the exponents differ by 3. The tricky thing is, which way do I move it? So my unit is getting smaller, 0 to negative 3. So since my unit gets smaller, my number must get bigger. So I'm going to go 3 spots over to the right. So that would give me 50 milliliters. Another way to do this would be use dimensional analysis. So if you wanted to do that, you would do the 0.5 liters over 1, put liters down on the bottom, milliliters on top. So if you know that in 1 liter there's 1,000 milliliters, then you're just doing 0.05 times 1,000, which would also give you 50. So that is a third way to go ahead and calculate it. In my experience, I've found that people either tend to do them in their head or they use this method. So we'll practice a couple more with that method. So we have 1,200 milligrams to kilograms. So milli is 10 to the negative third. Kilo is 10 to the third. So now we are going to need to move our decimal 6 whole spots. Now, our unit is getting bigger, -3 to +3. Therefore, our number must get 6 places smaller. So we shift this over 1, 2, 3, 4, 5, 6. Sorry, that was a little messy there. It would be 0, 0, 1, 2. Because we had to move it over 6 spots. So if we take a look at that again, since my original one got a little messy, we would shift it over 1, 2, 3, 4, 5. So you'd add in a 0, 6, add in another 0. All right, number 4, this is decagram. So this is not one you would have on a test because it's not on your reference table. That's 10 to the first. Hecto is 10 to the second. So I'm only going to have to move the decimal 1 spot over. And my unit is getting bigger, so my number has to get smaller. So that would be 7.5. All right, we've got 560 dm, so that's decimeter, so that's 10 to the negative first, and km is kilometer, so that's 10 to the third. So now we're going to have to move our decimal 4 spots, and my unit is getting bigger, so therefore my number has to get 4 places smaller. So I'm going to move my decimal over to the left-hand side. 1, 2, 3, 4. So 0.056. All right, if you're good, pause the video and try the rest of them and then check your answers. If you're still not loving this, I'll go through some other ways that you can solve for them. All right, so we have joules, and then we are going to microjoules. So if we want to do dimensional analysis, we have 0.65 joules over 1. Joules is going to have to cancel. Micro. Joules goes up in top, and my base unit is joules. I know that in 1 joule, joule again is a unit of energy, there would be 10 to the 6, which is a million microjoules. So they're very tiny, so my number is going to go up. 0.065 times 10 to the 6 would give me 6.5 times 10 to the 4th, or 65,000. So you can write it either way, 65,000, or if you would prefer, 6.5 times 10 to the fourth. They're both the same thing. All right, number 7, we have picometers. So very, very teeny tiny, 2 meters. So my number is going to get smaller. We'll go back to the exponent method for this. So pico, 10 to the negative 12th, 10 to the 0. So you have to move the decimal 12 spots over. So you could either actually take it and do 12 spots over or do scientific notation. That is your call. So once you move the decimal over, I put mine in scientific notation. I got 7.525 times 10 to the negative 9th. But you could have left it in number format. It would be a decimal, 8 zeros, and then the 7525. And again, picometers are very tiny. So if you're going to measure them in meters, you are going to get a very, very, very small number. All right, last one. We got 925 nanometers to millimeters. Nanometers are also very small, 10 to the negative 9th. Millimeters, still small, but much larger than a nanometer, 10 to the negative 3rd. So therefore, we will need to move the decimal 6 spots. My unit is getting larger since a millimeter is larger than a nanometer. So my number has to get smaller. So we will get 6 spots smaller. So we are going to be a decimal, 3 zeros, 925. Or you could have had it in scientific notation. That would be 9.25 times 10 to the negative 4th. Now, it is important that we can understand our metric system conversions, but to be perfectly honest with you, the most common ones that we are going to be doing are things like, grams to kilograms, joules to kilojoules, millimeter and centimeter. So the ones that, we'll get a little bit more familiar with, but we should be able to do all of. Very last thing we have is percent error. You would have done this also in Earth Science. The formula is on the reference table, so we don't have to memorize it. These little lines here mean absolute value. So it doesn't really matter what order you subtract the two in. Let's say you get a negative 12% error. That still means you were 12% off, so we just drop the negative. So it doesn't matter which order you subtract them in, but accepted does have to go on the bottom, and accepted is our real value. And you figure out which one is accepted by reading comprehension. So methyl alcohol boils at 65 degrees Celsius. A student measures it to be 68 degrees Celsius. What is the percent error? So my measured is 68. My accepted, the real value, is 65. Divided by 65 times 100. So I have 3 over 65. And then times 100, and I'll just write that out. And I get 4.6% for that. In our case for lab, anytime our percent error should really be about 10% or less, with the exception of a few labs that either I know that we can get the results really good, then I would want to see you 5% or less. And then we also have a couple of labs throughout the year that I know sometimes the results don't come out the greatest due to our equipment. And so then a larger percent error would be expected. But usually we should be able to get under 10%.